In this video, we're going to look at vector composition. That is, taking two or more vectors and composing them into one resultant vector. We'll be looking at graphical means of doing this, and there are two ways of doing this graphically. One is with the parallelogram method, and the other is with the tip-to-tail method. You can also compose vectors using trigonometry, but we're not going to do that today. So first let's look at the parallelogram method of vector composition. So here I have two vectors, okay? And they go in different directions, and so in order to figure out what the resultant vector is, we need to do some sort of vector analysis to compose these two vectors. The way to do vector composition with using parallelogram analysis is the first thing you have to do is you have to put the bases of the vectors in the same place. So I'm going to take this vector here and I'm going to erase that, and I'm going to put its base right here, and that's about the same length as the other one was. Let's just make that one about like that. Okay? And so you'll notice one thing with vector composition using graphical analysis is that it all depends on how accurately you draw the vectors. Once you have the bases in the same place, then you complete the parallelogram by going to the tip of each vector and drawing a line that's parallel to the other vector. I'm going to draw a dotted line so you can see it better. So from the tip of this vector, I'm going to draw a dotted line that is at least roughly parallel to the other vector. And from the tip of this vector, I'm going to draw a dotted line that is, at least roughly, parallel to the other vector. Okay? Where those two lines meet, the parallel lines that you just drew, right here, that's where they end. They end where they meet to complete the parallelogram. And then if you want, you can draw your arrows on the ends of these to indicate that that's where they're going. The resultant vector then, using the parallelogram method, starts here where the base of the two vectors started and goes all the way down to the other corner of the parallelogram. So this here is actually my resultant vector, this red one starting here and going all the way down here. So if you had two forces represented by these two black vectors, the actual effect of those two forces would be a force in a single direction with a greater magnitude going in that direction. Now that we've looked at the parallelogram method of vector composition, let's look at the tip-to-tail method. Or some students find it helpful to go in reverse, the tail-to-tip method. But however it works for you is good. We'll go over it as we go. So in the tip-to-tail method, you have a variety of vectors. The nice thing about the tip-to-tail method is it's not limited to two vectors as you are in the parallelogram method. So let's just start with one example. Let's say I have a vector here. Let's say I have another vector here. And I have another vector there. Okay? And so I have three vectors, and I want to combine these. All right? So using the tip-to-tail method, what you do is start with one vector, it could be any of them, and you take the tip of that vector and you bring the tail of the next vector up to it. So here's my first vector. I'm going to take this tip and I'm going to put it to the tail of this one. So that is roughly the same length as that one. Alright, so there's my second one. He's taken care of. And then my third vector, I have to take the tail of that vector, put it to the tip of this vector, okay? And I'm going to go back that way, something like that, okay? My resultant vector then starts at the base of my first vector and ends at the tip of my last vector. So this, I'm just going to draw it just a little bit lower so you can see it. But this then, right here, would be the resultant vector. That green one here would be the resultant vector of those three forces. That's an example where all the vectors are moving basically in the same direction, horizontal, left to right. Let's look at another example where they are not doing that. So let's just draw some vectors up here. Let's draw one, about like that. I'm going to draw one, that's about like that. And I'm going to draw another one, that's about like that. Okay, so now we have three vectors, and we want to compose those three vectors. Well, again, from the tip of my first vector, and you can select any of them, but from the tip of my first vector, I'm going to draw the tail of the next one. So that'll go about like that. Okay, he's taken care of. Now from the tip of that one, I'm going to start with the tail of my next one. That's what's called tip to tail. Alright, and that one goes down about like that. Okay, that takes care of him. Now, to figure out the resultant force, the resultant vector, that is the net effect of all three of these forces going at the same time, I simply start where I started. Always start where you started, at the base of the first vector, and draw an arrow to where you ended. That is to the tip of that last vector, and that is my resultant force. So you simply take your vectors and line them up one after the other, and then start where you started, end where you ended, and that becomes your resultant vector.